Okay, thank you. So as we've seen from the very interesting talks this morning, due to the dominant Q mode of Gemini, we've always done a substantial amount of time domain astronomy. So historically, as you can see from the plot here, we've typically observed about 15 to 25% of the time observed in band one as TOOs, or targets of opportunity, which are observations where the target is not defined at the time of the proposal. And this leads to max target opportunity rates per night of one or two events, which is relatively easy to handle, but the process is rather manual, is not as efficient or capable as it could be. And in this new era of time domain astronomy, with all these new large surveys, as we've heard, ZTF, in a couple of years, we ran an LSST in the various MMA facilities. For example, LIGO starting 04 next year, we must be prepared for a higher rate of targeted opportunities. So in this talk, I'm going to give you an update on improvements that are underway so that Gemini can reach a strategic goal of being a premier time domain follow-up facility, as well as protecting and make it easier to do all the non-time domain observing that we need to do. So to put this in context, I want to give another view of the time domain follow-up system the community is putting together. On the left, we have the surveys and facilities that are generating alerts and streaming them over the internet. Those are collected by the brokers, such as Antares that Monica mentioned, which catalog and classify them. Then in the middle are the science teams, which use systems such as these TOMs, the target observation managers, to collect, the filtered alerts that they get from the brokers, do prioritization, and then submit observations to the facilities on which they have time and collect back the data for further analysis. And this is where we find the AEON network. So I'm going to be focusing on the middle and right parts of this diagram, extending on what Monica showed. So a little bit about instrumentation. Obviously, the facilities have to have instrumentation that are available conveniently. In this context, I want to emphasize that basically all the Gemini facility instruments can be used for TDAs, also a lot of the, especially the long-term visitor instruments. But it's really the workhorse optical near infrared instrumentation will be the most useful because it's on a telescope most of the time. So this gives a view of the likely instrumentation suite from the mid-2020s. In the north, it'll be mostly still GMOS and GMERS, and in the south, GMOS Flamingos 2, and in a couple of years, hopefully Scorpio, which will do optical and infrared simultaneously. I should also note that it is possible to use the relay systems for TROs, but you need to put the trigger in a few days early so we can go through the laser clearinghouse process. A little more on these target observation managers, or TOMs, which the teams use to match the targets with their telescopes. These are basically interfaces on top of databases, which will store all the targets. As you can see here, you can do queries on brokers, so you can bring in the filtered objects of interest. And then there are interfaces in the GUIs for doing the observation submissions. And these are in use by a lot of teams who study supernovae, exoplanets, solar system objects, and microlensing. But they're also useful for non-time domain projects, anything that has a lot of targets, or you have a lot of team members that you need to manage. And as has been mentioned, Las Cumbres observatories made these really easy to put together using this TOM toolkit. You can actually go from nothing to a configured system that you can start to tweak for your project in 15 minutes. I did a workshop at the virtual science meeting last year, which shows how to do that. So please check that out. So once the observations are submitted to the facilities, they need to be scheduled and observed efficiently. And it's easier to do that if you have a network of facilities, especially with different apertures, which is a reason that my lab is collaborating with Las Cumbres Observatory on AEON, the Astronomical Event Observatory Network. It's an effort to develop and promote a accessible, dynamically scheduled system of telescopes. So the main projects activities have been to develop the interfaces to do this, both internal and external, We use SOAR as a pathfinder, which is now running behind the Las Cumbres scheduler, and we do queue observing on dedicated AEON nights throughout the semester. We incorporate Gemini. We've investigated and implemented tag processes to enable the use of the network, and we encourage data pipelining and archiving efforts, and we want to be ready to incorporate new facilities as they come online, such as the Reuben in-kind contributions, the Bronco, and others who are interested. So the AEON working group and the Gemini board have discussed for several years the tech processes needed for this. And it's very important that we meet the participant requirements for proposal evaluation. With the use of the network, will require multiple proposals. Proposals for Gemini time go to the national tax systems, just like we do now. Pending proposals for the non-Gemini time will need to go to those facilities. For example, the facilities allocated by the CSDC NORLAB system, you would apply through the NORLAB for US time on Las Cumbres and SOAR, and you can take advantage of the US Open Skies policy. When we were putting this together, we realized that the AEON requirements lend themselves really naturally just to general multi-facility proposals. So that's why in the 22B pit, we put a new AEON or multi-facility option in the QA classical proposal tab here. So if you are putting in a proposal for multiple facilities for the same projects, you should set that to yes. And then you have the option of popping up this dialog here. You can specify whether a particular instrument that you're requesting is required or absolutely essential for your project. Obviously, everything you're applying for is important for you, and you're justifying that. But certain of these may be more important or essential than others, such that if you don't get the imaging that you're going to use to actually find the transients, maybe the whole thing won't be valid anymore. And the second thing is that we don't show the TAC of this information. This is used by the staff internally to track what's going on after the TAC process and during the scheduling, just to avoid any bias in the TAC evaluations. So you should also describe and justify the roles of the various facilities in your experimental design and use for their facilities section. So Gemini, as we've seen with Monica's example, currently works within AEON via this plugin that we wrote for the TOM toolkit using some APIs we already have. This program provides interface for both manual triggering, as you see here, and automatic triggering, such as Monica showed, using this very basic API, which allows the submission. It works okay, but it's not as capable as we'd like it to be. And I should mention that the Observatory Archive also has APIs which allow taking and downloading of raw data. So I'm going to show a little video here which shows how this works at the moment. Monica showed how you can do this with the Jupyter Notebook, and this is how the interfaces can be used. So I've imported a ZTF target into my TOM, and I'm checking the visibilities on the different facilities. So this looks good. I'm going to submit the Gemini observation. So I pick a standard TOO template. I'm going to make a grouping. I'm going to set the slit along the parallactic angle. So that means a date. Set the brightness. Setting one as constraint types of notes for the observer. And now the TOM's going off and finding a guide star and submitting the observation. That's done. There's the entry in the database that corresponds to it. I go to my observing tool, sync, and there's the observation with all the information from the TOM, including the slit, the guide star. But the real advantage of this is being able to do this automatically. So here I've defined a browser or a broker query, which will trigger automatically anything that meets the criteria that I programmed in there. So let's found two. One rapid one went to Gemini South, so the pop-up appeared for the observer, so they'll react to it quickly. There's all the information, and I'm going to switch authentication to Gemini North and sync, and there's a standard TOO, so no pop-up there with all the information. And back in my TOM, the database has records of all this, so I can track them and download the data later. The Gemini will better support AEON via this Gemini program platform and Gemini projects. The GPP is the core of a new observatory control system. It's the high-level software that we use for operations. Designed to be easier to use, it replaces the current phase 1 tool and the observing tool desktop applications you have to download every semester with a set of web applications communicating with the database in the cloud via some interfaces. It will allow Gemini North and South observations in the same program. There's a lot of automation. It has the constraints we need for an automated scheduler and makes the code a lot more maintainable. So you can get some hands-on experience with this at the workshop later this afternoon. So Explorer, which is the main application for doing program and proposal preparations, will also allow you to find the capabilities that you need without having to go through all the instrument web pages like you do at the moment. So here's one part of it. You can specify in spectroscopy and then enter your science requirements like the wavelength, the resolving power, the signal to noise, and when we put a limited selection, these are the things that we have that will do that science. And as soon as you pick one of those, your observation is basically done. The integration time calculator has been run, so we know how long it takes, and the sequence has been generated automatically to meet that signal to noise. So this is a new way of doing future TDAs. You don't have to define the template observations, such as I showed in that video with the Tom. And everything that can be done with Explorer UI can be done programmatically. So the full program information can be accessed with scripts. You can add targets and observations, edit them, and remove them if you want. This figure shows Jupyter Notebook I did last week when I created the GPP database for the list of observation of targets in my program. And I use this line, I created a new target, and there see it shows up in the list. Another run command, I take that target and create an observation with it. It shows up down there. And using the automation that I mentioned before in GPP, about automatically selecting an instrument and then creating the sequence, that's basically done and it will be submitted as a trigger. So again, not necessary to prepare these TDA templates in advance, which can be a little limiting. So we expect to start GPP early science and testing phase, which we call XT, in early 2024. The XT1 phase, we'll start with a call for proposals to do GMAS imaging in long slit, hopefully October next year. We'll be requesting about 5% of the telescope time to do the reasonable evaluation of GPP. We're going to request these proposals, then do the observing of a set of fixed nights with GPP, do a full end-to-end test, fill out the scheduler, and so that we can refine the system as we go. The XT2 begins, so from then on we're implementing instruments and modes, and after one is done, we want to try it out, so we'll probably be requesting that people convert existing programs into GPP, and we'll try observing with that. Maybe giving a time bonus as a motivation to try this out. And we expect full operations currently in 2025. And we certainly want to have the system sufficiently developed that we can do Scorpio commissioning before then. So as Explorer gets more developed and we implement more features, we are gradually ramping up the community testing. The workshops at this meeting are a first step in that direction. So the testing will be, test driving it, trying to break it, throwing in questionnaires, doing quantitative tests so we can measure this against the previous system. So come to the workshop this afternoon and let us know if you're interested in participating in this. So Gemini is also implementing this real-time schedule that I mentioned and real-time data reduction as part of the NASA-funded Gemini, or Gemini in the Area of Multi-Dimensional Astronomy project. The scheduler passed its final design review last May, so we're under construction right now. It will do updates to the plans in real time as things change, as TROs come in, as the weather changes, adapting to it as it goes. We schedule Gemini North and South together. As a sort of mini network, this figure on the right shows schedules for Gemini North and South with our prototype scheduler that was done. The same schedule around in less than 15 seconds to do both of those. The real-time data reduction is done in the Dragon system that you've heard about in talks by Kathleen and Monica. Just to go over it again, supports GNSS imaging in one slit. There's quick look for quality assessment is working with telescopes now, and the science quality reduction is in progress. It will be released next year along with the needed archive updates. So in summary, Gemini is aiming to be the promote year class member of a follow-up network that will consist of these various pieces, the brokers, these times, dynamic scheduling, a range of network of telescopes of various apertures with various workhorse instruments and real-time data reduction. And to do this, we are constructing this new observing system, which will support the follow-up that make Gemini easier to use for everybody. So your involvement is really important. So we build the right thing for you. So please get involved in the workshops, and thank you. And I'm willing to take any questions.
Questions? Okay, go ahead, Ricardo.
Thanks, Brian. I have two questions. The first one is very general. So from explosion to spectrum, what do you think is the weakest link so far? And the second is, so with the TOM, you're sending information to the database and the OT, but do you also get some information back? For example, the warnings from the OT, like I cannot find a guide star, things like that. Do you get it back, or you have to check on the OT?
Currently, no, you didn't get it back with the API. That's one of the limitations. You would have to check the OT for that. With GPP, you will be able to get all of that information. The weak link on our side, and once we get the trigger, the problem we're just keeping track. No, we can show the observer responding properly, that they can make a proper decision about whether to know when they need to switch to a new target, is it interrupt or not, and then they have to, in their head, basically switch the rest of the schedule around, and that wastes a lot of time. So there's just a lot of extra excessive mental overhead, which we want to get rid of. So we'll get suggestions like, here's a new event, let's either interrupt now or it come in later, and the plan will just automatically refresh. So you can focus on what you're doing and getting the best data for people.
Hey, Brian. So in the era where we're going to have, instead of now, like there's 10 alerts, 100 alerts, and getting RTOs rapidly at Gemini, is there going to be, like, let's say you get 20 RTO requests in a night? I don't know whether that's even possible in the era of LSSD, but maybe. And if that does happen, is there going to be a ranking system built into the software, or is that going to be reliant on contact scientists and everybody at Gemini to look at it and be like, okay, we need to do these instead of?
We need to build in all of the policies for that. So we have this policy for competitive TOs to handle things that are trying to do the same target or coming at overlapping times. So we'll have to implement all of that. We'll have to keep track of when things came in and do them in the appropriate order based on the ranking bands and all of that, so that people don't have to take up time thinking about it. That was a big problem with the gravitational wave Villanova. Everyone wanted the same targets, and I imagine there was a lot of discussion going on, lots of phone calls to work out what to do.
Okay, so it's going to be built into the.
To build all that in. Yeah.
Julia.
Thank you for all your work that you've done on this. This is exciting. I was wondering, you were talking about kind of the limitations of the TOM right now, and then you talk about how GPP is going to solve all of these, but of course that's coming after 04 happened
Yeah.
in March. So are there any things that you're doing to, patch that, make the time work a little bit better until GPP comes on?
Actually, not planning to do much with the current interface. The more we do with the current system, the slower GPP is. Because it's the same people supporting both systems, so we're trying to do absolute minimum, just get by with the current system as much as possible. As much effort into GPP and get it in place as quickly as possible.
Okay, great. Thanks.
Any questions on slide?
No question.
Okay, I think we can end our session now. Janice, you have.
Yeah, let's give a round of applause to all of our morning speakers.